In your notebook, we're going to be talking today about thermohaline circulation. Greenland is melting. So here's what we're going to do in your notebook. I'd like you to go to a new 2-page spread. And the first, on the right page, I'd like you to write thermohaline circulation. And for me, put cold, salty, deep. Huffman, I have 628. Choo, that's not the right day. It's 629. Sorry about that. Fix that date. And when you have that set up in your notebook, we're going to go ahead and set it up for, Bill's going to do a second part of this, or at least talk to you a little bit about a second part. And if you turn the page, you can put thermohaline circulation, Greenland is melting, Bill, and fix my date. It should be 629. Once you have that, we'll go back to the page with my name on it. Everybody with me so far that's at least back in your seats?
I think I missed the first part.
Okay,
so what was
you're going to just open your notebook to the first 2-page spread and write thermohaline circulation, cold, salty, deep, and my name as the presenter. Got a mistake on the date. It should be 629, not 628.
cold, salty?
And then Bill's going to follow it, but if you don't have that page yet, we can add that later. Okay, so I just wanted to tell you while you're finishing that up a little bit about where I came from in my teaching career. I actually started out as a special ed teacher, and I taught K to 12 my first year as a first-year teacher. That was ridiculous. Then I went and I taught K to 6 special ed, and then I went into a special ed first grade classroom. Then I changed schools and I taught third grade. I taught first grade, then third grade, then fourth grade, then fifth grade, then back to fourth, back to fifth, and then I went to junior high. And in the middle school, I taught 6th grade math. I taught 7th and 8th grade. Highly gifted is where I ended my career, teaching the highly gifted students who were 2 years ahead of the regular students and a year ahead of the regular gifted students. So their IQs started at 150 and went up from there. They were the top 1% of our gifted population. And at that level, I taught 7th grade science and 7th and 8th grade language arts and social science. So we kind of taught the whole child in that program. During my time, a lot of, you can imagine in elementary school, a lot of it was from, my background came from literacy and also teaching special populations because my master's is in special ed. So I feel like, Bill said your science notebook is your most important tool. And I'm going to say that maybe literacy may be your best science tool, especially working with students who have come to science with English as a second language, or maybe your first generation college students who might not have as much science background. And literacy may be a really good tool for them. So when we're talking about a high school chemistry class, there's 6,000 new terms that students have to learn in a high school chemistry class. That's a whole new foreign language. So we have to be really aware of the terms that we're using. So I'm going to give you an example of what I'm talking about here. Let's take a word like microbiology. Now, you guys are all familiar with this term, but maybe one of your students might not be. And what we want them to start doing is looking at these terms and saying, is there any part of that word that you know what it means? And for example, in this one, if we broke this apart into micro and bio and ology, They might know that micro is too small to be seen with the naked eye. They probably know what a microscope is and things like that. Um, they might know that ology is the study of. And they might know that bio means life, like a biography is the story of someone's life. So then we take this, all of those pieces of that, and we can put it together into the study of life too small to be seen by the naked eye. And then just by looking at those parts of words, and sometimes when they're coming to us from a different language, they have a little bit of maybe the understanding of some Latin in their language, some words in their language that would fit in this too, pieces of it that make sense. Then I got to thinking when I was talking about this that science is always coming up with new terms. I mean, think about it. In my lifetime, and I'm a lot older than most of you here, but in my lifetime, there's a couple of new terms that have come about from science, like astronaut and cosmonaut. I mean, think about it. The moonshot happened in my lifetime. I have an encyclopedia that has in under moon, it says someday we might be able to travel to the moon. And I kept that encyclopedia because it's hilarious to me now. But astronaut, astro means star, so a star sailor, not nautical. Cosmonaut, a sailor of the universe. The Russians made up a word for their astronauts. So, and scientists are constantly making up new words, putting pieces together to explain what they're doing. So let's go back to this term, thermohaline circulation. A lot of you may know what this means. A lot of you may have even studied it in your research. Some of you may not. My guess is most of your students have not heard this term. So I want you to step into your students' shoes for a second. Think about thermohaline circulation, the words. And I'd like you to go to your annotate tool, and I want you to just think if there's any words that your students, any pieces of this that your students might say, oh, that might mean this. And just annotate a few things that you could pull apart from that word and say, and see if we can get some meaning out of it from the parts. Go ahead and get your annotate tool. Okay, we're starting to get some things up there. So a lot of you are pulling out that therm and thermo, meaning temperature. That's outstanding. And then I don't see anybody taking apart haline. Do you think that there's any part of haline that your students might know or not know? Now, you guys, I think some of you are putting up things that are coming from you. Some of your students may know some of these things, but are there some of them that you might think, again, you're trying to get into their head, how might they pull it apart? I like that circula, circle. A lot of you are saying haline rock salt, haline salt, halite, okay? If they took basic geology, they might have pulled that out. So excellent. So we're just kind of pulling this apart. And when we think about that and we talk about, we're going to talk about the thermo part of this word, and then Bill's going to talk about the haline part in just a minute. So, but I'd just like to leave you with that for a second. Just kind of think about how you might help your students start to think about the language of science too. That literacy piece is really important. So thanks for playing along with me on that. So now I want to clear, I hope I can do this. I'm going to clear off what you said because they're going to stay on my screen. All right, this is what we're going to do now for this demo. I'd like for you to get out your 6 cups, and you're going to have to get up probably to do this, which will give you a chance to move around again. I was feeling like I really needed to stand up there today, so I wanted to put this break in here with your cups. It's not really a break, this is a setup time. So you've got 6 of your cups. You're going to set up 2 of them with hot water. Now, I would suggest either you heat it up in a glass container and bring it back to your cups, or maybe not glass, or you might heat it up on the stove with a teapot or a pot. Be careful if you're going to carry it back to your desk. Now, your 2 cups of hot water, you need to color it red. And in your kit, you were given both blue and red food coloring. So when you color that hot water red, I want you to make it a good, strong color, but it needs to be transparent. You need to be able to see through the color, but make it strong because we're going to be doing some things with these. Same thing with blue. Now you want cold water. It can just be tap water, but put ice cubes in it, get it really as cold as you can. And you're going to just fill these cups up to probably let's say the 190 milliliter line. There's no real measurement. Just don't spill food coloring on yourself. It'll stain. So 2 hot water cups, color them red, make it a strong red, but make it transparent. Same thing with the cold water. Color it a strong blue, make it transparent. You want to be able to see through it enough to see how the colors move. You have a cup that's going to have no water in it. You're going to put 1 ice cube. You could write these things down in your science notebook if you have to go to another room and take your cups with you, or however you want to do this, but you're going to want to do that. Lukewarm plain water in the last cup. That cup can be hot water out of your tap. That'd be fine. Any questions? You think you could
Can you say one more time? So 2 hot, 2 cold, 1 lukewarm. What's the last one?
Cup with no, can you see the screen? The screen has it on the screen.
Last one, we can't see that.
You can't see it?
Yeah, I can see. With ice cube in that.
Yeah, the one has no water and has 1 ice cube. So
okay.
2 red hot, 2 blue cold, 1 no water with an ice cube, and 1 lukewarm water, plain water, no color. Okay, let's give you 5 minutes. Go stand up, move around, and get these cups set, and we'll come back.
Luis, does the water need to be boiling or just like hot
Just
tap,
hot.
really hot tap water?
Yeah, don't put the cups in and melt the cup, but put it in a microwave. No, you should make it hot, as hot as you can get it.
Okay.
Microwave it in a glass container, or just heat it up a teapot or something like that. But make it hot, hotter than tap. Okay, so this first one, we're going to be talking about circulation in the ocean generated by temperature differences, so that thermo part of the word. And we're going to start with your lukewarm cup. So Bill is going to do it with you, Khaldun. And what you're going to do is you're going to take your ice cube and you're going to gently place it in the water. And you're going to have your blue food coloring in your other hand. So you've got your ice cube, you've got your blue food coloring ready, and you also want to be able to lean down and look at your cup from the side and really watch what happens, okay? So everybody get your blue, got your lukewarm, got your ice in it, and here we go. You can unmute yourselves if you want. It feels so lonely out here when it's so quiet. I'm glad to see faces, but okay, you ready? Get ready with your blue food color.
Can you put the first screen where you had the bottles? Because I was downstairs warming the water.
Right now, do you have lukewarm water and an ice cube?
Yeah, I am getting a regular cold water.
Okay, we have to go. We're gonna have to go, but if you can get your lukewarm and an ice cube just in it and your blue food coloring, what we're gonna
Okay.
do is you're gonna drop a drop of blue onto that ice cube and then get down there and look at your cup and see what
So
happens
cool.
when that blue hits that ice cube. Ah, Karen's already seeing stuff. Thanks, Karen.
The lukewarm water was plain, right, Louis?
Yes, plain water, ice cube, a blue drop on the ice cube. Get down and look at it. It's pretty cool.
Very cool.
So unmute yourselves and let's just share a few observations. What do you see happening with this? This is a very simple demo, but what do you see happening?
Whirling.
In mine, the food coloring went straight to the bottom first, and then it came back up almost like a lava lamp.
Did you put it right on the ice cube and you said it slipped off the ice cube, or did you?
Mm-hmm.
Okay.
Yeah.
What about some other people? What else? And it came back up like a lava lamp. I like that. Who else noticed some things?
Yeah, I have it. It came down like a thread.
Okay, like a thread out of the bottom of the ice cube or off the side, or?
Off the side, and then it seemed to curl back up again.
Okay, who else? What else have you seen?
Mine was kind of thread-like, bunch of like little ones, like kind of water falling down. Pretty cool.
Cool.
Cascading.
The other thing I noticed now is that the whole cup of water is turning blue, even though it was one drop. So it must have circulated in that cup somehow.
Okay.
I can see the bubbles coming out of the ice cube.
Okay. Color bubbles, blue bubbles?
Yeah, white from the top. It's sticking to the side.
Okay.
Same here. Mine is the same.
Blue bubbles also, yeah.
So and then what we're seeing is you're seeing the blue, that you've got the difference in temperature because you've got that cold, that ice cube, you've got the lukewarm water, and you've actually seen some currents in some of your cups, actually in this small little cup, an actual current getting set up where it's going down, it's come back up. Dominic said it actually mixed, and that'll happen in the ocean. So we're gonna try a couple of other things. You're gonna need one of your red cups, one of your blue cups, and you're gonna need a pipette that's also in the bag.
So just a quick question, Louis. The blue cup is where the cold water is, right?
Right.
Okay, so I am just pouring my hot water. Okay.
And the red is the red hot. So.
Okay, let's get cold water.
So I'm gonna tell you what to do here next, but I want you to watch the slide so you can see it. So Rose, can you see your slide? I think I lost Rose. Well, let me do it so you guys can get started and we'll get Rose caught up here. You're gonna take your pipette and you're gonna pull up blue water into it. And you're gonna, now here's the trick. If you squeeze it really hard and fast, you're gonna cause it just to mix without seeing what the temperature causes. So I want you to put the drop on the side of the glass and gently drop the blue water into the red water. And get 2 or 3 pipettes full of water and do this, and then get down and observe. You want enough blue that you can actually see it happening. So go back, get blue water again, drop it into the red. So you're putting cold into hot. And what happens?
Cold water is settling down below the hot water.
Okay, so you're seeing cold water going to the bottom and settling down. Is it moving after it gets down there?
Okay, let me watch.
No, it's settling down.
Just settling down, okay.
It's from the other side, it's coming a little up.
Okay, so it was kind of went to the bottom, slowly moved over to the other side, and then kind of went up.
Yes,
Okay.
yes, yeah.
Okay. And you can keep adding some blue to it if you want and see if more blue, what happens.
It's mixing now. The water is becoming a different color.
Okay, which is why you have 2 blues and 2 reds because it'll be purple here in a minute. So, little art project too, while we're art and science. Okay. So can you make any statements that from the evidence that from your observations, what happens when cold water and the warm water come together when you're adding cold water to the hot water? Can you make any observation, make a statement about what you've seen?
Let's see.
Based on the data we've seen or observations, the cold water is heavier because it sinks than the warmer water that stays on top.
Okay. And I wonder why it went over to the other side and came up. So let's try something else here. I want you to take the other 2 cups, your other red and your other blue, and another pipette. Probably a clean pipette would be a good idea. And I want you to watch the slide because it took me about 1,000,000 years to get this animation. So you need to see it. Don't miss it. Okay, so you're getting more red and you're going to do the same thing. Again, you're going to drop the red, this time the hot into the cold, and gently, because you don't want to use energy to make it move, but you just want the temperatures to be what's making the water move. Drop your water in. You can do 2 or 3 pipettes of the hot water. And again, observe it really closely. And hi, Bess, glad to see you. I'll be done in just a second. Bess, while they're doing that, I'm gonna give you co-host power. So when we get to me not sharing my screen, you can just go right to yours. Okay, so what are some of the observations? What happens when warm water or hot water goes into the cold water? What are you seeing?
I got color layering. It's a little bit.
And what kind of color layers? What do you see? What are you seeing? Where are the colors?
Okay.
I think I made my blue too dark.
Yeah, my the bottom is light, but the up is a little bit darker. Do you get the same thing?
When I did this, that's why I used my experience when I was giving the directions. I practiced this a whole bunch, and I found it took me a while to get the right color, dark enough that I could see the differences, but enough transparent enough to see through it and see what's happening. Is there anybody that can actually see the layering and tell us how it ended up layering?
Well, the bottom is lighter, the top is different color, a little bit.
Can you see where the red and blue are?
It doesn't go out anymore.
I have pink on the top.
Yeah.
Pink on the top and blue on the bottom. Does anybody else get pink on the top or red on the top, blue on the bottom?
Yeah.
Okay.
So one thing that helps with this is if you actually pipette against the side of the cup and let it slide down instead of pipetting into the water.
Right.
So what happened is the blue color is a little bit overwhelming, but red color we could see a lot easier. With the blue, it's kind of a more camouflage color. It makes it a little harder.
It's really a neat demo too. If you do this in a plastic shoebox and you have the different waters in it, you see a couple of things happen. You'll see the layers really well. And you'll also see when you first do it, you'll get the blue sinking to the bottom like it did in the first 2 demos. and the red, pushing the red up, and the red will sink on the other side. And I think it was Paramita that said the blue went down and then came up the other side. So as it goes down, it's kind of like, if you think about the North and South poles and those areas with sea ice, you've got the sea ice is ice that's frozen from the ocean, and then the water right underneath it is very, very cold for a couple of reasons and very dense. So it will go to the bottom. It pushes down and up toward the equator, and as it gets closer to the equator, warms and rises. So from both poles, you'll get those big, gigantic thermohaline circulations going from the polar regions. So one of the things that we want to end up thinking about and talking about is what happens when we change the amount of temperature, what if we change the temperature of the ocean, and Bill's gonna, I hope we get him in maybe this evening that he can talk about his, because the haline is the salt part that we haven't talked about yet. And I'm afraid that we'll see where we come up on time, but Bill will be able to share that at a later time. So basically, this is just a demo to get your students starting to think about how hot and cold water work together. Very simple demo, getting them talking about it. And you can make it a short demo or one that you actually demonstrate, but we really like for the kids to have their hands on it as much as possible. And in a cup, it's pretty easy to do. So